Okay, so in this video, we're going to look at disproof. Okay, we want to show that a set does not form a group under the binary operation. And to do this, we just need to show that one of the four axioms is not satisfied, or there's actually an alternative. We can also reference Latin square property. Okay, the fact that every row and column must have each element exactly once. Because if it's a group, it must be a Latin square Cayley table. So if we have a look here, we got the operation star defined on the set A, and we've been given the Cayley table. We need to show that it's not a group. So let's reference the Latin square property first. Okay, so if we have a look in the first row, we have two tens. Okay, so what we can say is that the Latin square property is not satisfied since 10 appears twice in the first row. Okay, then I can say therefore A does not form a group under star. Okay, and that will be sufficient to pick up what would probably be a 1 or 2 marker. Okay, we're also going to look at an alternative way of potentially disproving this. So another way of thinking about it is we have 10 combined with 10 gives us 10. Okay, that implies that 10 is the identity. Okay, remember the identity must be unique. However, we also have that 20 combined with 10 also gives 10. Okay, so this implies that both 10 and 20 are the identity. However, the identity must be unique. Okay, so we can conclude it can't be a group based off that. Okay, so that's another alternative way we could have done the disproof. I will do one more way. Okay, so another way we could potentially do this is check associativity. So pick 3 elements. So I'm going to pick 10, 20, and 30. Okay, and what we're going to do is we're going to combine these together in 2 different ways. So we're going to do 10 and 20 first. So if we do 10 combined with 20, we get 10. And we still need to combine with 30. Well, 10 combined with 30 gives me 20. Okay, now let's do it another way. So I'm going to write out the initial statement again. But this time I'm going to put brackets around the second 2. So if we do 20 combined with 30, we get 10. And if we do 10 combined with 10, we already wrote that out earlier, we just get 10. Okay, and that means we've shown that 10 combined with 20 first is not equal to, so therefore that's not equal to 10 combined with the 20 and 30 combined first. Okay, so we can conclude therefore not associative, so it also cannot be a group. You only have to do one of those ways, but potentially it might be a Latin square, so you might have to use one of the second 2. And we didn't actually investigate inverses because the identity didn't actually exist.